Sorbitol, Wikipedia audio. Sorbitol, less commonly known as glucitol, is a sugar alcohol with a sweet taste which the human body metabolizes slowly. It can be obtained by reduction of glucose, which changes the aldehyde group to a hydroxyl group. Most sorbitol is made from corn syrup, but it is also found in nature, for example in apples, pears, peaches, and prunes. It is converted to fructose by sorbitol 6-phosphate 2-dehydrogenase. Sorbitol is an isomer of mannitol, another sugar alcohol. The two differ only in the orientation of the hydroxyl group on carbon 2. While similar, the two sugar alcohols have very different sources in nature, melting points, and uses. Sorbitol may be synthesized via a glucose reduction reaction in which the aldehyde group is converted into a hydroxyl group. The reaction requires NADH and is catalyzed by aldose reductase. Glucose reduction is the first step of the polyol pathway of glucose metabolism, and is implicated in multiple diabetic complications. The mechanism involves a tyrosine residue in the active site of aldehyde reductase. The hydrogen atom on NADH is transferred to the electrophilic aldehyde carbon atom. Electrons on the aldehyde carbon-oxygen double bond are transferred to the oxygen that grabs the proton on tyrosine side chain to form the hydroxyl group. The role of aldehyde reductase tyrosine phenol group is to serve as a general acid to provide proton to the reduced aldehyde oxygen on glucose. Synthesis. Sorbitol is a sugar substitute, and when used in food it has the INS number and E number 420. Sorbitol is about 60% as sweet as sucrose. Sorbitol is referred to as a nutritive sweetener because it provides dietary energy, 2.6 kilocalories per gram versus the average 4 kilocalories for carbohydrates. It is often used in diet foods, mints, cough syrups, and sugar-free chewing gum. Most bacteria are unable to use sorbitol for energy, but it can be fermented slowly by a group of orally found bacteria called mutans streptococci, thus potentially causing tooth decay unlike xylitol, which is considered to be non-acidogenic. Altoids mints, sugar-free, breath savers, wintergreen mints, double mint gum, Eclipse sugar-free gum, Hershey sugar-free peppermint patties, Icebreakers sugar-free mints, Life Savers sugar-free Window green breath mint, Stride sugar-free gum, Trident sugar-free gum, Wrigley's Orbit sugar-free gum, 5 gum sugar-free. Common products containing sorbitol: gum/sugar-free candies, ice cream, syrup, jelly/jam, Breyer's light and no sugar added ice cream, Edie's carb benefit and no sugar added ice cream, Blue Bunny reduced fat and no sugar added ice cream. Beverages: lozenges, Mrs. Butterworth's sugar-free syrup, Hungry Jack butter sugar-free syrup, Log Cabin sugar-free syrup. Uses: it also occurs naturally in many stone fruits and berries from trees of the genus Sorbus. As is the case with other sugar alcohols, foods containing sorbitol can cause gastrointestinal distress. Sorbitol can be used as a laxative when taken orally or as an enema. Sorbitol works as a laxative by drawing water into the large intestine, stimulating bowel movements. Sorbitol has been determined safe for use by the elderly, although it is not recommended without the advice of a doctor. Sorbitol is found in some dried fruits and may contribute to the laxative effects of prunes. Sorbitol was first discovered in the fresh juice of mountain ash berries in 1872. It is also found in the fruits of apples, plums, pears, cherries, dates, peaches, and apricots. Sorbitol is used in bacterial culture media to distinguish the pathogenic Escherichia coli O157H7 from most other strains of E. coli, because it is usually unable to ferment sorbitol, unlike 93% of known E. coli strains. A treatment for hyperkaliemia uses sorbitol and the ion exchange resin sodium polystyrene sulfonate. The resin exchanges sodium ions for potassium ions in the bowel, while sorbitol helps to eliminate it. In 2010, the US FDA issued a warning of increased risk for GI necrosis with this combination. Sorbitol is also used in the manufacture of softgel capsules to store single doses of liquid medicines. Sorbitol often is used in modern cosmetics as a humectant and thickener. It is also used in mouthwash and toothpaste. Some transparent gels can be made only with sorbitol, because of its high refractive index. Sorbitol is used as a cryoprotectant additive in the manufacture of surimi, a processed fish paste. It is also used as a humectant in some cigarettes. Sweetener. Laxative. Beyond its use as a sugar substitute in reduced sugar foods, sorbitol is also used as a humectant in cookies and low-moisture foods like peanut butter and fruit preserves. In baking, it is also valuable because it acts as a plasticizer, and slows down the staling process. Smucker's sugar-free jam. Medical applications. Healthcare, food, and cosmetic uses. Miscellaneous uses. Medical importance. Adverse medical effects. A mixture of sorbitol and potassium nitrate has found some success as an amateur solid rocket fuel. Arizona Diet Tea Drink. Sorbitol is identified as a potential key chemical intermediate for production of fuels from biomass resources. Carbohydrate fractions in biomass such as cellulose undergo sequential hydrolysis and hydrogenation in the presence of metal catalysts to produce sorbitol. Complete reduction of sorbitol opens the way to alkanes, such as hexane, which can be used as a biofuel. Hydrogen required for this reaction can be produced by aqueous phase catalytic reforming of sorbitol. Brach's wintergreen lozenges. The above chemical reaction is exothermic, and 1.5 moles of sorbitol generate approximately 1 mole of hexane. When hydrogen is CO-fed, no carbon dioxide is produced. Overdose effects. Sorbitol-based polyols are used in the production of polyurethane foam for the construction industry. It is also added after electroporation of yeasts in transformation protocols, allowing the cells to recover by raising the osmolarity of the medium. Aldose reductase is the first enzyme in the sorbitol aldose reductase pathway responsible for the reduction of glucose to sorbitol, as well as the reduction of galactose to galactitol. Too much sorbitol trapped in retinal cells, the cells of the lens, and the Schwann cells that myelinate peripheral nerves, is a frequent result of long-term hyperglycemia that accompanies poorly controlled diabetes. This can damage these cells, leading to retinopathy, cataracts, and peripheral neuropathy, respectively. Aldose reductase inhibitors, which are substances that prevent or slow the action of aldose reductase, are currently being investigated as a way to prevent or delay these complications. Sorbitol is fermented in the colon and produces short-chain fatty acids, which are beneficial to overall colon health. People with untreated celiac disease often present sorbitol malabsorption, as a result of the small bowel damage. Sorbitol malabsorption is an important cause for persisting symptoms in patients already on a gluten-free diet. The sorbitol hydrogen breath test has been suggested as a tool to detect celiac disease because of a strict correlation between cutoff value and intestinal lesions. Nevertheless, although it may be indicated for research purposes, it is not yet recommended as a diagnostic tool in clinical practice. It has been noted that the sorbitol added to sodium polystyrene sulfonate can cause complications in the GI tract, including bleeding, perforated colonic ulcers, ischemic colitis, and colonic necrosis, particularly in patients with uremia. Risk factors for sorbitol-induced damage include immunosuppression, hypovolemia, postoperative setting, hypotension after hemodialysis, and peripheral vascular disease. SBS sorbitol should therefore be used carefully in the management of hyperkalemia. Ingesting large amounts of sorbitol can lead to abdominal pain, flatulence, and mild to severe diarrhea. Habitual sorbitol consumption of over 20 grams per day as sugar-free gum has led to severe diarrhea, causing unintended weight loss or even requiring hospitalization. In early studies, a dose of 25 grams of sorbitol, eaten through the day, produced a laxative effect in only 5% of individuals. Compendial status. One explanation for this overdose effect could be the large molecular weight of sorbitol. At 182 g/mol, sorbitol is poorly absorbed by the small intestine because it approaches the upper limit for diffusion across the small intestine epithelium. As a result of this, when large amounts of sorbitol are ingested, only a small amount of sorbitol is absorbed in the small intestine, and most of the sorbitol enters the colon. When large amounts of sorbitol are ingested, the fermentative capacity of the colon can be exceeded, and gastrointestinal effects can result.